Hello everyone, this is Keith Jackson and welcome to Jack's Math Notebook. In this video, we're going to continue our study of similar figures, keeping in mind that similar figures have congruent angles and proportional sides. And what we're going to do, we're going to look at two similar triangles, and then we're going to look at two similar rectangles. Let's go to our first big example in which we have these two similar triangles. We have a small triangle and a big triangle that happen to be similar figures. And here's what we're going to do because they have congruent angles and proportional sides. What we're going to do, we're just going to create this little tic-tac-toe chart right here. And this C stands for congruent, this P stands for proportional. And in this case, because we're trying to find the length of X right here for the big triangle, well, we're going to put sides right here. Okay, and so what we're going to do, we have this S right here that stands for the small triangle, and this B right here that stands for the big triangle. And what we're going to do, we're going to put the dimensions of the small right here, and then we're going to put the dimensions of the bigs right here. Smalls with smalls, bigs with bigs, y'all, okay? And so let's take a look at what we have right here. So what we're going to do in order to find the length of X for the big triangle, what we're going to do, we're going to use this double arrow right here, and we're going to use it this way right here for the small triangle, and we're going to use it exactly the same way for the big triangle. And so for our dimensions right here that we're going to compare, let's just compare 3 inches with 5 inches, right? So we have these two sides right here. We're just going to leave this one right here because we don't really need it. We could just use these two. If you want to, we can use these two, but I'm just going to take the easy way around. I'm just going to use my double arrow right here to have 3 inches and 5 inches for the small triangle. And then I'm going to do exactly the same thing for the big triangle, in which I have 6 inches and X inches right here, because I'm trying to figure out the length of this hypotenuse right here for this big triangle, right? So here's what I'm going to do. Because I have congruent right here, I'm just going to put the small triangle right here. Then I'm going to put the big triangle right here. And then I'm going to put the dimensions of the small right here in this space. And so right here, I have a 3 and a 5. And what I'm going to do exactly the same thing for the big triangle. I'm going to put a 6 and an X. Notice how I'm following the arrows, right? 3, 5, 3, 5, 6X, 6X right there, just like that. Notice the proportion, right? Because 3 is proportional to 6. And I have it right here. 3 is proportional to 6, which lets us know that 5 is proportional to X, right? And so all that remains at this point is to cross multiply to figure out what X is going to be. And so when we cross multiply, we have 6 times 5 will give us 30, while X times 3 will give us 30 as well. And so here, what we have right here, we have 3X is equal to 30. And then the question is, what number times 3 will give us 30? And that answer is 10. So we know that X is equal to 10 right here, y'all. Okay, let's go on to the second big example in which we're going to compare two similar rectangles. And the dimensions of the small rectangle will be 7 centimeters and 9 centimeters. While for the big rectangle, we have 21 centimeters and unknown centimeters right here for its length right here. And so again, we're just going to apply our congruent angles proportional sides to this because we're trying to find the length of the side of the big. And so here's what we're going to do. We have our congruent, right? And so we got our small right here, our small rectangle, and then we have our big rectangle right here. We're going to put smalls with smalls and big with bigs, y'all, right? And so notice that we have this double arrow, one pointing at the 7, one pointing at the 9. Well, I'm just going to plug that in right here with the small dimensions, right? So I have a 7 and a 9 right here, and I'm going to do the same thing with the big dimensions in which I have a 21 and an X, and I'm just going to park that right over here, noticing that for the proportional side, right, this 7 is proportional to 21, as you see right here, just like that. And this 9 is proportional to X. All right, so now we have this, and all we have to do is cross multiply to figure out what X is going to be. And we know that 21 times 9 will give us 189, which lets us know that X times 7 will have to equal 189 right here, right? Because the equal sign cannot tell a lie, right? So again, 21 times 9 will give us 189. X times 7 will give us 189 as well. So we know that 7x is equal to 189. And when we divide both sides by 7, x will equal to 27. So right here, x is equal to 27. Okay, you have been given a lot of information. I wouldn't blame you if you need to pause this video to take a look at these diagrams or replay this video as many times as you need to gain a deeper understanding of this concept. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.